Hello, everyone. Welcome. We'll just wait we're just on the hour, so we're going to get started right away. Just a second for me to get to the slide and we will be on our way. Thank you for joining once again. It's definitely always a pleasure to host and have you join the conversation. This one would be nice. Okay, come on. Sorry, just a minute, some technology. We're down. Okay, great. Sorry about that. So we will be on our way now. Hello, everyone. Welcome to the June edition of the Africa Share and Discuss webinar series. My name is Shola Olateju, Africa STEM specialist at PhET Interactive Simulation at the University of Colorado Boulder. It's always a pleasure to have you. Thanks for joining us again. We're always excited, and this edition promises to be as insightful, and we hope we'll continue to carry the conversation even into the different groups and platforms we have to continue to support us. I have a couple of people, of course, joining us for the first time, but we'll have enough time to share. We also have our speaker already on the call, who I'm going to allow to introduce after some bit of housekeeping rule and a bit of an introduction about what PhET is. I'm going to hand it over to her to speak, but just before then, we also would like to know you. So if you're joining us here on Slack, please use the chat feature, write your name, the subject you teach, and the country you're joining us from. If you're joining us via Facebook, please also post into the chat feature there on Facebook, either beneath the video stream there, the country you're joining from, your name, and the subject you teach, anything about you, anything you're looking forward to during the session as well. We'd love to know. This session is recorded and will be made available after the session of course, for those who want to catch up again or for those who are unable to meet it. Our speaker is going to introduce herself in a bit, but for those joining us for the first time, this webinar is brought to you by PhET Interactive Simulations, like I said earlier on, in partnership with the MasterCard Foundation. What is PhET? PhET was founded in 2000 by the Nobel laureate winner, Carl Wyman. The PhET Interactive Simulation project at this institution creates free interactive maths and science simulation. PhET teams are based on extensive education research and engage students through intuitive game-like environments where students learn through exploration and discovery. They emphasize making connection between real-life phenomena and underlying science principles, and make visualizing and help to make visual and conceptual model of scientific concept accessible to students. So our goal is basically to make learning STEM more like doing STEM, because they are more involved as against being passive in the classroom. Currently, we have up to about over 190 simulations across the different, across math and science, then across the different age levels. Of course, you can visit our website to learn more. We're going to have some time at the end of the day to share links, so please just listen through. In line with this goal, we have a couple of initiatives, which is one of which you are joining today, which is the Share and Discuss webinar series. So through this platform or through this series, we meet every third Wednesday of the month, and we bring together researchers based in Africa as well as African educators to share insight around the use of PhET. The goal is to basically improve the practice, but most importantly, ensure that these tools are effectively used for optimal outcomes in our classroom. So the educators and the researchers basically share evidence-based strategies to support the effective use of PhET-Sims in our classrooms. A few housekeeping rules before I introduce our speaker. So we've saved time. While this session is ongoing, you will not be able to ask. So please use the question and answer feature if you are here on Zoom. Please write in the question and answer feature any questions that come up, any question that might come to mind while the conversation is ongoing. We've saved sufficient time after our presentation where we will address all of our questions, and hopefully we'll have enough time to cover it all. We always ensure we do, perhaps stay back a bit if we need to. But if we do not, of course, we'll take that to the group to continue or write back directly to any questions we're unable to attend to. Similarly, if you're joining us via Facebook, please write in there. A member of the group definitely is looking out for all of your questions, and we will get to them. We have the link to the group if you also would like, if you would like to join to where you can connect with us as well. So today, without further ado, I have the pleasure of introducing Mafor Penn. Mafor is a science lecturer at the Department of Childhood Education at the University of Johannesburg. Her research focuses on technology-enhanced science education, the affordances of science, of virtual and augmented reality, and of VR in science teaching and learning, mobile learning in science education, as well as inquiry-based science education. She has an array of publications in reputable journals and various national and international conferences. She also won accolades for one of our publications, winning the Chancellor's Medal in 2020. Today, she's going to be sharing from many of our outcomes and learnings over the years from the use of PhET, of course, as an educator, but also as a researcher, what she's learned and how we can pay more attention to how students perceive this tool and how we can what we can do to ensure we elicit the right attitude from them to support the outcomes we desire. Thank you so much for joining us, Mafor. I'll hand it over to you now.
All right, thank you so much, Shola, for that warm welcome and for all the accolades that you've added to some of mine. Thank you so much. I really appreciate PhET for this initiative. I also appreciate you, Shola, and the team, and Rebecca and Zach, for all that you've been doing so far. It's been phenomenal. Can I go ahead and share my slides? And I also welcome all those who have joined the session. And I'm really happy that you have taken out this time. It's going to be quite insightful. Just stay put. And yeah, let me reach out the best way I know, right? I will just quickly share my slides. Is that fine, Shola?
Sure, please go for it.
Okay. All right. Okay. So
just a minute, Mafor. I think you might want to. It's showing the presenter view now.
Okay, it keeps doing that. Okay, I'm just going to stop sharing for a bit again.
Yeah, sure. Go for it. Hello, everyone. Yeah, please write in the chat. We would love to know you. While we try to get the slide on, please write your name, the country you're joining from, the subject you teach, and if there's anything you'd love to learn about PhET within the context of this conversation or out of that, please feel free to use the question and answer feature, and the member of the team definitely will get to that and ensure you get responses.
Shola, can you check my slides again, please?
Yes, there's this button somewhere in the bottom right corner. I think that might be a quick way to get to it. Yeah, just if you go a bit right or just beside the minus button, there's the zoom. There might be some lag. Or please feel free to use what you're comfortable with. Just beneath the university logo, there's a slide. There's a standing screen icon just there. That should, I would expect that should make it easy to go directly. Do you see it? Can you see the slider? Oh, okay. Okay, while we wait for her to join again, yeah, so it will be interesting to see, do we have anyone with a question or anything you're looking forward to from this conversation? So students are at the center of the simulations. Yeah, Mafor, please go ahead. Once you have the slide up, you can continue. But you would agree with me that students come with a lot of, okay, great. Thank you, it's up right now. Please go ahead. I'll save the question for later, everyone. Please just hold it up.
Okay, thank you very much, everybody. Thank you for your patience as well. All right, so today I want to present to this, this novel discourse, the way science students perceive and their attitudes, of course, towards simulations, but in particular towards PhET simulations. And in my presentation today, I would want to, give you a bit of a background of where I have come from. My name, as you have already heard from Shola, is Mafor. I used to be a physical sciences teacher starting from 2009. And somewhere along my teaching, I discovered the simulations and I started using them. So for at least a decade and more, and some, I've been using these simulations, and I've found that they are very useful tools for a science teacher. Again, in the African context, they come across as tools that are a lifesaver in the case that you don't have a lab or you don't have models in the classroom. So today, I would like to share with you on some of the perceptions and the attitudes towards PhET simulations that students generally display. I will move on, and Shola, please just let me know if this thing is moving from your side, because I seem to be experiencing some slowdown. I don't know why that is, but I'm just going to try and see if it does the same thing. So is it changing from your side?
No, not yet. So it's still on the title page where we have your head and your name.
Okay. So I seem to be experiencing this slowdown, and this was working just fine. But I'm just going to do that again one more time.
Technology, yeah.
Those are the ills of technology.
But if you can, I don't know, if you have it online, if you share it with me while you're speaking, I can also help troubleshoot that, so you're not distracted.
Okay.
If you share with me, then I'll take it up from there while you continue to speak. Apologies, everyone. We're going to get back right in a bit. Don't worry, we're not going to miss out on the conversation, and of course the time we've saved for questions. We want to be sure, like, you can follow through with the conversation while the slide is on.
Yeah.
Make all of the conversation as visual as possible.
Okay, so I'm just going to step out and share this with you.
Yeah.
I think I need to stop share again.
Yes.
There's just a little bit of a glitch on my side. And then I'm going to share with you again. I don't know why. We had already done the test, and it's surprising how this happens. Okay, I'm just going to do that again from the beginning. I'm sorry for the delay.
Yeah, please go for it. Thanks, everyone. I can see, of course, our introductions have been dropped in the chat. If you have questions while the session is ongoing, like I mentioned earlier on while discussing the housekeeping rules, please use the question and answer feature just in the lower part of your screen where you can post your questions and we'll get to it. So there'll be about 20 minutes towards the end of the session where we're going to take time. Of course, you can ask directly to Mafor what these questions are in line with the conversation. But if you have any other question related to PhET and how, of course, you can receive support, bring it to your school, also write in the chat and the team will get to that. Thank you, Gary from Uganda. Thank you for joining. I also see Talo from Setswana. It's great to see Momade from Mozambique. We have such a diversity. Thank you. It's great to see educators across the country. We have Apia from Ghana, Adamu from Nigeria. We have Etienne from Rwanda also on the call. Thank you for joining. If you're on Facebook, yeah, I'm definitely going to get to that. Yeah, please go on, Mafor. If you're ready. Do you want to go to the next slide now? I think that should.
Shola, I don't know which of the views are you seeing here? Which of the views of these slides are you seeing?
It's the very first slide, I would assume. So it has the title and your name. Okay, so technology is being very nice today. So while we try to troubleshoot this, it will be interesting to hear from us as well. What are the attitudes? What are the things we've noticed? What are the attitudes we've seen some of our students display when we use this tool in our classroom? You can write in the chat, but if you also, if you would like to speak, yeah, please just raise your virtual hand and we'll definitely love to hear from you as well. We've used the SIM, of course, for those of us who have experience using it. We've used this in different contexts. What are the common attitudes you've seen students display? What are the ones that perhaps you found favorable, some of them not as favorable? Who would like to share that experience with us? Anybody while? So if technology continues to be a challenge, Mafor, I think it's okay to proceed with the conversation, sadly, and I will get the slide across to everyone shortly after the meeting.
Okay, that's fine. Thank you so much, Shola, from your side. I don't know why I have these glitches, and we had already done test show and everything was fine.
Yeah.
Okay, no problem. Let me just continue with the conversation, and I would have really loved to show more in terms of what is it that students see as perceptions, and then what are the associated attitudes that come from these perceptions that are developed. So in this presentation today, I intended to talk a little bit more about the background and the theory, and to just look at, of course, the learning challenges in the science subjects across the board. So we are talking about biology, chemistry, physics, and in some cases, astronomy. And then you want to also look at some of the implementation setbacks, because when it comes to simulations, people will typically have a couple of setbacks that are related to technology, but some of them are not quite related to technology. They are quite focused on the context in which we are. And again, on the continent, there's a whole lot of issues that come with incorporating technological tools in teaching. And then I wanted us to just look at some of the applications, and as well as the implications for practice, for research, and also for designers of learning technologies. So I'm just going to try again, Shola, and if you would permit me, I would probably just share this on a non-slideshow mode. I think that's where the whole glitch was coming from. And if you can see now, I'm going to leave it like that, if you can see that, okay? So I'm going to look at the fundamentals of what simulations are. And Shola, you would have already started my presentation by actually defining them. These are interactive tools and digital tools that can help to imitate processes and systems, as you know, because you would want to say that no, the imitation part exactly may not be accurate, but what we see, especially with PhET simulations, is that right to the 90% mark, the simulations are able to mimic biological processes, chemical processes, physical processes, as well as astronomical processes. So it's quite an insightful affordance of simulations, as we can see. And simulations can be in 2D or 3D, as we have already heard from Shola's side. And you would know that in science education, they are actually meant to enhance visualization, to enhance the understanding of abstract concepts and the visualization of certain pathways that you may not be able to see, even those that you're familiar with. For instance, within your own system, you cannot see how the blood is moving around, but a simulation can, for instance, show you that process. So PhET simulations are a lifesaver. Colleagues and friends and all teachers present there, they are a lifesaver. These were brought to us by the University of Colorado, Boulder, and we are grateful. I can't emphasize how much that these simulations have meant for me as a science teacher throughout my career. I just want to use this opportunity to share some background. Okay, so I'm going to teach a brief chemistry lesson in just 2 minutes, okay, because my time has been taken. So if you look at the typical example, which is the build an atom simulation, you will find that this simulation has 3 interfaces here at the bottom: the atom, the symbolic, and then a game. Now, in this short chemistry lesson, I would like to quickly say that if you look at the lesson, if I use this lesson, I will teach learners about the elements of the periodic table. I will show them how an atom is represented. For instance, I would say that an atom is made up of subparticles called protons, neutrons, and electrons. And if I put in a proton, it gives me the particular element of the periodic table and where it is positioned. Okay, so the proton number or the atomic number tells you where that element is positioned. If I add a neutron together with the proton, it gives me the total mass of an atom. And if I put the electrons on the shell, it shows me whether this particular atom is neutrally charged or it is a charged particle. So of course, you can always use this interface in different ways. Now, from my side as a teacher, the emphasis will be that these representations make one to visualize. Notice how if I now change this atom to a helium atom by adding 2 protons, and I want to add the second electron, okay? I want to add the second electron. Notice how if I put it on the first outermost shell, which is supposed to take 8 electrons, it does not respond. It's going to move to where it's supposed to be. Talking about the games, if I choose a random game from this interface, let me choose a random one. This game is basically checking now whether you can know what the charge of this particular atom is. What is the charge of this atom? For me, this atom is neutral because it has 2 protons and 2 electrons on its shell. If I check it, it's going to give me a smiley to say, okay, I did well. What if I'm that student who does not know this? And let me move to the next question and I pretend I don't know this, okay? Now we all know that the mass number is the proton, the number of protons plus the number of neutrons. So ordinarily the mass number of this element right here or of this atom is supposed to be 22. And for instance, I give it a 10. And I take it. You will see the negative smiley that says, I have not done well. And it gives me the opportunity to remediate. So you have that opportunity to try again. And if you try again and you put in the right thing, of course, is going to give you that smiley. All right. So I hope we are able to see that. So from my experience as a science teacher, it's amazing how this little smiley here brings so much joy to the hearts of a learner. It brings so much affirmation to say that they have understood or they know the concepts, and they'll do it over and over again until it becomes part of their practice. That brings me to what the relationship between perceptions and attitudes are. So when you look at psychology and all the psychological concepts, perception is defined as, understanding a phenomenon, what leads to the understanding of a phenomenon, the way you understand it, the way you interpret it. So if I say I have a good perception of what PhET simulations are, is the way I have understood it, the way I have used my sensory organs to perceive it, to see it. What is it to me? How do I make meaning of it? How do I interpret it? Then if you look at attitudes, it's a response to those perceptions. And you will see that typically you can define attitude as the actions towards an object. So if I have a positive perception of something, or I really love something that I'm doing and learning, I will tend to have a positive attitude. And the tendency is that if I have then a negative perception, it will lead to me having a negative attitude. So the summary of it is there at the bottom, that how one perceives something will determine how they show attitude towards it. And that has been the case for me with PhET simulations. The affordances are enormous, and you can see that in real sense of the matter, how learners perceive simulations and how they show a particular attitude towards those simulations will help in their learning process. Okay, so that is where, as teachers, as teacher educators, as teachers in practice, those who are preparing to become teachers, I will admonish you to use this tool. Now, notice how these simulations are freely given to us by PhET. We are not going to buy it. PhET has made it freely available for research, for education, and it is being supported by diverse establishments and organizations. And I must confess that it is not me selling. So you may want to say, Mrs. Penn, okay, you are selling this thing for PhET. No, we are not selling. This is research. This is evidence-based practice that I'm presenting to say that these simulations have the ability to stimulate learners' interpretation of concepts. Just like you saw in the demo that I did, that little smiley has the ability to put a smile in a learner's heart, even as they are trying to grasp these concepts. Okay, so this is you using a tool that has been proven to be effective for science learning. But then what are some of the challenges in science learning or in science education? You'll find that the first one is the nature of abstraction, that learners are not able to visualize concepts like atoms, electrons, molecules, particles. You're talking about forces and charges, and you expect them to understand. This is very abstract. Okay, and then science is also multi-representational in nature. For instance, if you look at light in physics, it's a form of energy. But then also you will know from the theory of relativity that light has particles referred to as photons. Yes, the student can see the light. Okay, of course, you can even touch the globe and see that it is warm and it's generating some heat energy. But it's difficult for a student to see the photons. So these are some of the challenges for science concept formation or for learning in general in science. Now, also, even though the advocacy, for inquiry-based learning has taken over reforms in science, you find that there are resource limitations in the learning process. We can boast of, well-equipped labs for all learners in Africa or in the world for that matter. So we'll say that there's a shortage of resources in terms of showcasing the affordances of science. And then you have the typical problem of overcrowded classrooms, poor attitudes towards science itself as a subject, because you go to certain schools, you find that the learners are demotivated towards science. It might be due to a bad experience. It might also be due to the fact that they have not been taught the subject in a way that it is simplified. Now, there are other contextual factors that I may not go into today because, I mean, it's quite, diverse in different contexts, but you find that there are some schools in which, the learners, they are not privileged to even have a science teacher. And when they do, they'll get somebody from the low tier who is not well trained to teach concepts. And there's a lot of debates around that, how teachers are deployed, especially in Africa. So it's a whole lot of things. So, but then we want to emphasize in this meeting that, PhET simulations can address these challenges in many ways than not, okay? The first is that, from several research findings, and you'd find there that I've cited a lot of some of my own research, as well as other researchers' work here in Africa, you'll find that they can dissipate abstract concepts. They can also enable visualization. If I am wondering how a particular force is acting, I can actually go on to a PhET simulation and I can show that, all right? And if I'm wondering how the movement of a field, a magnetic field is, I can go on to a PhET simulation and actually visualize that. So they are able to dispel certain misconceptions. And I can say this is also a double-edged sword because sometimes simulations actually cause misconceptions in the learning process. So that's why you have 2 stars on there. And you as the teacher, you have a fundamental role to scaffold these misconceptions, whatever they may be. If it's correcting the misconception, make sure you scaffold the learning. If it is dissipating or if it is creating any kind of misconception, the role of a teacher kicks in there. Okay, so the simulations, in essence, from my side, are not a standalone tool. They are not a one solution to all problems. It needs educators to be committed. It needs people who are able to understand them and use them adequately. They are able to enable inquiry-based learning, especially in contexts where we don't have traditional labs. They are able to complement lab-based science work, because if you can use a simulation to prepare for that acid-based titration before you go into a lab, you will be well equipped to enact that. All right, so you use it to complement that which you're going to do in a lab. And again, this is a two-sided affordance, because you find that students report that, okay, the simulation is good for lab work, but then it does not really help me to grasp certain science process skills that I need to know physically. So this is a complementary tool. It enhances conceptual understandings, as you can see, the Chinaka article and several others. It stimulates interest in science and science careers, and it also enhances the big issue that we are here today for, perceptions and attitudes towards science. So the question here, colleagues and friends, is that, can science be fun? Of course, yes. Can it be interactive? Of course, yes. Can it be a motivational tool for learners to take up STEM careers in the future? Of course, yes. Simulations are able to afford us all these privileges with adequate use and with good support. Now, there are some implementation setbacks that you would see in our context. Some of them include issues with connectivity and power, issues of the fact that in lab-based sciences, students would report back that they need to know the actual handling of skills, of equipment in a laboratory, how to measure things, how to eye gauge things, and to align things, and to pipette solutions and things like that. And then there is also been a whole debate from my studies, the ones that I personally did on pre-service teacher education, where they've said, these technologies tend to cause learners to over-depend on technology and want the technology to do everything, but that is not the case. Advocacy today is that simulations are a complementary tool. They can make a drastic difference if you complement your teaching strategies, or you complement your teaching with these simulations and other teaching strategies. Now, what are the implications for everyone? The first and good thing here is that there is a wider than imagined impact of simulations on science learning. So if you look across the board, you would find that wherever these simulations have been used, especially with good planning, there has been a positive shift in learners' understandings and in the acquisition of science process skills in general, and reasoning, critical thinking. They are able to think critically. It is also advocated that this integration of simulations is not a one-man show. We need a partnership of stakeholders, teachers, students, researchers, developers, and institutions. You know, like I would actually use the opportunity again to thank PhET Simulations for this opportunity, you know, and for the fact that they have given this tool that has helped so many educators. So it's a partnership. We must work together. Now, where possible, you have to incorporate this technology to be able to enhance learners' use of technology. In this age, learners tend to be more digital than ever before. So if you have the opportunity, add this to your pedagogical repertoire, use it for your teaching, and also encourage learners to use it for their learning. And yeah, we also advocate then for researchers to take up larger scale studies, probably international studies, where we can do a comparative analysis and really see the impact of simulations like PhET. So I have a few recommendations, and I think my time is almost up, Shola. I have a few recommendations here for practice that teachers and teacher educators must make efforts to integrate simulations in science teaching. In as much as there may be labs, in as much as there may be models and charts in your classroom, I think the big difference comes when a student is able to do something over and over in a virtual space and finds that there is no limitation of time or geographical location, because this builds perception. It builds a good attitude towards a subject. If a person is able to sit in the comfort of their bedroom and learn these difficult concepts, instead of running to the school or to the campus, to a lab, you know how this will be impactful. It will help them to learn. It will help them to remediate. For researchers, I advocate again that there should be larger scale studies, if it's possible, a design-based research to look at design principles for integration, to look at pedagogical strategies and the theories that support the efficacy of these simulations. Okay, and then for policymakers, it's about time. We've said it over and over, and you know, it's amazing how in some cases, policymakers will actually laugh at us in the face, but it's about time. If there are any policymakers in the meeting, it's about time that we integrate simulations in the curriculum, so it becomes mandatory for teachers to use them in certain concepts, because it's not in all concepts that these simulations may actually help a teacher, but in certain concepts, they will aid a teacher and they will aid the learning process. Now for designers and creators of educational technology, we just advocate that if you can probably scaffold interfaces, probably embed some assessments and games, like we see how PhET Simulations has done that marvelously in certain simulations like Build the Atom, chemical reactions. You know, there are games in there that will help a learner to learn more. You know, these will help the community and they will help the learning process. With that said, colleagues, friends, and everyone in the session, and all partners who are watching this discussed session, please support PhET simulations. Please, the uptake should proliferate rapidly across Africa because they come in handy. And I know the question will pop up that, in the case where the context does not permit, like we have power issues, connectivity issues, the technology is failing, teachers are not well equipped with that. That is why we are here. PhET has made it possible for support to come to us in all directions. There is activities online attached to the simulations. There are these chat forums and webinars where we can share ideas. There are workshops that have been made. And also you can find that you can download the entire simulation folder and save it on your computer such that when you use it, you do not need any connectivity. You do not need any connectivity. So as you can see, even from my slides, I've just embedded, I've used a functionality on PowerPoint to embed the simulations in my presentation. So friends and everyone in session, thank you so much for taking out time. And you will see there that I have cited quite a number of publications on there. I don't mind, these can be shared so that we can look at some of the evidence on this to say that simulations are God's gift, rather man's gift to science, and we are here for it. We are going to use it. We are going to improve science learning and teaching in general. Thank you.
Thank you so much, Mafor, for the amazing presentation. Thank you. Without any delay, we're going to open the floor up for questions. So this is a good time to use the question and answer feature. If you have questions at this point, we're going to get to them in a bit. While the questions are coming in, I have one question just to get us off. If you're on Facebook here, please write in the chat as well. Someone is going to pick that up and we'll come to this. So thank you, Mafor, but I want to pick up some of the things you mentioned, and one of them is, you did say something about the motivation students can come in with into a sim-based or a session where PhET is being used. Some of them can come from like the previous bad experience they've had that could have resulted in the perception that, oh, science is hard or difficult, or it's abstract and they cannot just wrap their head around that. Or the tough question often that comes to mind is like, how does this apply? How do I see this being used in real life? Like, it's just being taught in school and it does not apply. And of course, a lot of this can then affect how they react, just like you established. If you also consider the outcomes that the teacher are expecting, things around them, of course, improving engagement, helping them see that science is fun and relatable, of course, something that they can use in everyday life, as well as building a conceptual understanding. How does simulation help bridge that gap so that students can cross from the motivation and prior experiences they've had, and what are the things educators have to pay attention to help students cross from that where they have to the opportunities or scaffolds that simulations provide?
Okay, thank you, Shola. That's a wonderful question there. And thank you for asking that. So the first thing then you can see that PhET simulations are very peculiar and unique is that in PhET simulations, and for as far as I've used them, there are inbuilt scaffolds in there that would help usually to scaffold some of the learning and the process. But then a learner who has been demotivated due to misconceptions in the past, and a teacher who is about to bring that learner out of that place needs to plan well. So the first strategy there is adequate planning. Are you planning, or are you just throwing a technological tool into that I want to link to the simulation and plan how it's going to be done? Because we all know that if there is inadequate planning, the technology becomes a distraction. The learners will not use it adequately, and they may only get worse. So it's about planning, mapping the simulation to your curriculum, or to your learning goals for that lesson, and making sure that the simulation is used for that purpose only during your lesson. Now, out of the classroom, you can always encourage learners by providing some assessments. So what is in a lesson if you can plan and teach it without some assessment to assess how learning has happened? So attach your simulation to a learning objective and also to a matching assessment. Do you see that? Then it becomes a fantastic tool to take the learner out of the place where they are very demotivated or have misrepresentations to a place where they can actually self-teach autonomous learning using that simulation and also checking out their understandings using the activity that the teacher would have provided. So it's good planning, Shola. It's all about planning.
Okay, great. Thank you. Like we can't overemphasize the need to plan sessions and of course pre-plan opportunities to emphasize some of the opportunities that the SIMs can provide. Thank you for all of the questions, and please keep them coming. And I also see some of the feedback from the Facebook group. Thank you for sharing them. Just another question while we wait for more questions to come in, I'll run through them. The next question will be, from your experience, of course, students come with different attitudes or react to this tool. Some of them might see that as being fun and maybe get distracted with learning in certain cases. But what are the things educators need to pay attention to when, of course, tools like this are presented in front, as put in front of students, to make the most of them? So to be able to alter or maximize the reaction or actions or attitudes in the classroom. So what are the things you would advise from your experience that teachers should pay attention to in a SIM-based lesson with their students?
That's a good one there, Shola. So what is it that you pay attention to? The first thing here is, what is it that is abstract in that? Because the tendency is you want to know what is it about a concept that makes it hard to learn. So as a teacher, first find that aspect, okay? Now, like I said, I probably have said this in one of the symposiums or a discussion forum, is that if you can understand, for instance, those in biology teaching, if I can understand the sexual reproductive organs of a plant by bringing the actual plant or the flowering plant or the flower from the flowering plant into my classroom, having it being dissected using simple razors and then looking at the different parts, I do not need a PhET simulation for that. So what is it about the concept that makes it abstract? If you can identify that together with your students or with your learners, that's the first point. So that when you introduce that simulation that solves the problem, it becomes exciting. It becomes motivational. It becomes interesting, you know, and that is my first point, of course. So find that which technology can be used for first before going into the actual implementation. So you don't just present that lesson using any simulation because you want to. Look for that thing which makes the concepts a bit difficult, a bit abstract, and the visualization is poor, and then you add your simulation to it. That then answers the question of, wow, it brings in the aha moment in the classroom. It brings in the excitement to say, okay, now I can see. All right, Shola. And if you do not mind, I wanted to just show, for instance, one of those who are in session. I just crave your indulgence. Just one of the simulations that I used to have students talk about a lot is this one, whereby you could find that in this particular simulation is gravity and orbits. Students tend not to understand when you talk about the revolution of the earth around the sun, and also look at actually the rotation of the moon, which is the natural satellite around the earth. And then I tend to use this particular simulation. I'm just going to look at that interface. In this simulation, you can see here that I want to represent the force of gravity. I want to represent the sun, I want to represent the earth, And I want to, let me just see whether I can reset this. Okay, yes. I want to represent, and I'll make it a little bit bigger. I'm unable to put this on slideshow because it keeps freezing, but I want to represent the gravitational pathway, and I also want to represent the ellipse. So, and I play the simulation. You notice how from this simulation, students are able to visualize how the Earth rotates, revolves around the sun, but also how the moon rotates around the Earth as a natural satellite. You can do it very slowly, and that pathway can be easily monitored. Okay, it's very easy to monitor that, and it is also very easy for the students to be able to visualize the relationship between mass and gravity. Because if you notice how, if I increase the mass of our sun, it will pull in our Earth, and the gravitational force becomes stronger, and the path of the Earth becomes closer to the sun. These are some of the issues here. So the question is, what is it that they are not able to visualize first? Using a simulation, will it make the difference? If the answer is yes, then you go ahead.
Great. Thank you again. So I'm running through the questions now. Yes. Thank you, Bele Sukomi. Yes, the PowerPoint. I think Mafor just confirmed that she's going to make the PowerPoint available. So yes, we'll share with everyone after the session. Another question is from Kinese, and it says the presentation foreground the role of simulation from learner's perspective. What is the role of the teacher in a classroom where PhET is being used? I think you've answered some of this. I don't know if there's anything you want to add to what you said, or I can just go to the next one. So he's asking, we've looked at the students' role in this session, how we can ensure what the input in terms of their perception and their output basically is in line with our expectation for the session. And you earlier spoke to what teachers should pay attention to. So that's what I understand from his question.
That's
so
right.
We've answered that, so we can move on to that. And that's if I have to emphasize that it's more about presentation and looking out for opportunities to effectively leverage the scenes in a session. So practice, a preparation before the use of a scene is extremely important. So you can explore and identify channels, opportunities, of course, opportunities to emphasize or make some of the concepts that are difficult a lot more visible. Thank you, Rebecca. Okay, no, I think that's another question. Yeah, so please keep the question coming. I want to ask about, there's a deficiency in biology. Yes, so how can we make for that? Yeah, thank you. Increasingly, there are efforts. Of course, it takes a considerable amount of time to make the SIMs available. So the team is dedicated to constantly pushing out SIMs. But of course, we can't get to all of the topics at the same time. So of course, which is why we are always open and seeking collaboration to accelerate the effort and work we are doing. So if we're not there yet, yeah, please bear with us. And we're committed to ensuring that we can support as many subjects, as many concepts that we think is abstract. And something you can do at this point as an educator is also, yes, please write us, let us know the ones that you think are most important, where the gaps really are, that will bring a big shift. If you let us, that can also, of course, there are no promises, but that can also help us know how to prioritize and then what to focus on within the time, or as we plan around a couple of other things. So we have a few more minutes, so we can still take more questions. Okay. So I'm curious to know as well, Mafor, of course, you've carried out a couple of research around these tools. And of course, because you work with teachers as well, is there any other thing, like what is the one single thing, even beyond the students now, what is one big advice you have for educators in using this tool? Thanks or no thanks to technology, we know, we observed how technology can get really can get interesting during sessions like we experienced earlier today where there was a glitch. But what would you say is the one most critical thing alongside practice, or even aside practice, that educators should pay attention to in adopting and using these tools in their classroom from your experience?
Okay, thank you, Shola. That's a wonderful question. And yeah, thank you to all those who have put the questions in the chat. From my own practice is what I used to do, because in the kind of schools where I taught, there were days where we will have light and there were days where we don't have light. So what I did as a teacher from my practice when I was teaching is that if I'm coming to class with a simulation like the one that I am just using here, I will also bring an alternative plan, especially in the African context. We cannot always be free from some of the problems of the third industrial revolution. I mean, power cuts, electricity is out and all that. So I always have an alternative plan. I always have a backup plan. Like I said, for me, the simulations complement my teaching. I don't throw out all the other teaching strategies that I know, and then I solely depend on the simulations. I will bring something just in case that if it happens to be the case where I don't have connectivity or there is a power, because connectivity is never ever the problem with PhET simulations. That's the beauty of PhET simulations. I have them downloaded on my desktop, so I never have a problem with connectivity. The problem is usually power outages, whereby nothing can, it's only my laptop that might be working and the whiteboard in the class will not be working. So my advice to educators is, have you a well-planned lesson with also an alternative plan, just in case that technological tool that you're integrating in the lesson does not work. You just have an alternative plan so that the lesson does not fall out completely.
Awesome. Yeah. Thank you so much for these responses. Like, there are tons of validation and of course, like people clapping and sharing. Someone is saying, yeah, I have tears in my eyes. This is beautiful. This is great. My aha moments. Wow. So it's affirmation that many have found definitely the conversation useful. I'll take two more questions as we begin to bring the session to a close. Talo is asking, are there platforms, chat rooms, and forums where teachers discuss the benefits of PhET and showcase how they are using the tool? Yes, there are. So we have a community on Facebook. At the moment, it's I'll show that in a bit once I share my screen again. But you can find PhET Educators Africa on Facebook. If you look at the chat as well, my colleagues are going to drop that in there a bit. We have a growing community there where you can, of course, ask questions and someone will be available. Of course, we have people scattered across the world at different time zones. So you most likely will get a response from the team directly, but also from other members who have different experiences. Mafor is also on the team. So we have researchers as well who are also within the team. So yes, it's a large community of a mix of everyone. So all of your questions definitely will receive attention. Please take them. Then look out for the chat or just go on Facebook to search. There's another question here, which I think this will go to Mafor. This is coming from Beth. I think perhaps it shouldn't necessarily be limited to abstract concepts. The learners struggle to make the leap between what they do and the scientific process. She's emphasizing there are also opportunities even beyond the abstract concept, even the old visualizing and seeing how it applies in the real life has opportunities. Would you like to speak to that?
That's wonderful. Yes, I do agree. Absolutely. 100%. So my advocacy then to you then is that when you think of extending learning, the simulations will play a role. So it's really not just the abstract concepts. Sometimes it's just the difficult concepts. It's not even abstraction. Sometimes it's that this thing, people don't get it right. So the simulation opens the way. So I do agree with you 100%. To extend the learning, to just showcase processes, it does wonders for that. And what was the one thing I wanted to emphasize? The one thing that I would also emphasize as science educator, I've taught across the sciences, where there is need for authentic traditional learning, please use what is available. Don't make it a point to always add the simulation, especially in a case where there is an opportunity for you to use another strategy that is relatable. Yes, that's the emphasis. So let the simulation come as an afterplay, but let the strategy that may be relatable, that is right at the fore of you, be used, and you can keep the simulation aside in that lesson, because it's important for students to relate scientific knowledge to their day-to-day living, to their daily lives, to what they see around them.
Thank you so much. Their questions are still tripping in, but I think we'll have room for just two more as we close. I'll take another one from Talo again, I guess. Okay, no, this is from Kaziba Stephen. Is the desktop app also compatible with Linux operating system? Yes. So all of the SIMs are not platform dependent. So you can run them, you can download the app on the platform, but you can also run the SIMs independent. You can download them and run them in the browser. So if you have a modern browser that can run HTML5, every browser today can run that. So you can run all of the SIM as in seamlessly. So on mobile phones, on tablets, and on your computer or laptops, they run independent of the platform. But to make it easier, what we then have are apps that bundles all of the apps that are then platform specific. You can also explore that to just find the best use case for you based on how you do it. The size to download all of that in one pack can be challenging for some, which is why you also have the option to download them as individual pieces. So you can just use them as you find fit, as against downloading the big pack, which might be a problem considering bandwidth issues in certain areas. When educators use this tool, and we're going to end with this, Mafor, we'll just appreciate, we're on the hour, but we'll take this and we'll end with this. When training educators to use the tool, what have you noticed to be the biggest issue in terms of their technology savviness? So this is a bit different, but I think I would like you to speak with that. If you can speak to it in a minute, and we end with that, then that would be great.
Okay, yeah, Tyler, thank you for your questions. And Tyler, thank you so much. Sibusiso, I also see your questions about the grades. Tyler, let me answer that question very quickly. You know, when you train educators, to me, when I train, because now I am an educator trainer, the problem is not the use of the simulation. The problem is not usually the use of the simulation. Like I said earlier on, Tyler, if I use 2 minutes, I'll teach you how to use this particular simulation. 2 minutes, because of the way you are and because you're already very much of a digital learner, you will use 2 minutes to know how to use it. The real problem is with the content knowledge. And it's a fantastic question that you ask here. The real problem with teachers as the facilitator of these simulations is the content knowledge, because you cannot facilitate what you yourself don't understand. So the problem has never been with the use of the simulation. Of course, if I have this simulation that I'm sharing on screen here, and I say, okay, Tyler, you can just increase your screen by taking by dragging the key to the positive side, it's going to increase your screen. And these are the representations here, the sun, the earth, and the moon. And you can always increase and you can show the direction of velocity. The question now is, do you know what these representations mean as the teacher? So that is the big problem. It's never about the simulation. They know how to use the simulation. They know how to manipulate it. But do they understand the relationship between concepts? Because that is your role as the teacher. You need to be able to facilitate the understanding of concepts so that the learner will use the simulation for maximum gains. Now, Sibusiso asks, are there particular simulations for particular grades? Yes. If you pick up the PhET library with more than 190 simulations, as Shola had said, you'll find that you can just scaffold your curriculum. You take for South African students or South African teachers, you take your CAPS curriculum, you run through the curriculum against the simulation library. You will find wonderful simulations that speak directly to the outcomes of the CAPS curriculum in different grades, for different grades and for different learners. Yes.
Thank you so much, Mafor. I would like to appreciate you for sharing. Time is never enough, and of course, as much as we would love to continue the conversation, we will have to draw it to a close now. But it does not end here. Please, the link to the Facebook group has been shared. Please take all of the questions, all of the reactions, take it to the group, to the group on Facebook, and we'll be available. Like I mentioned, Mafor is there as well, so you can always connect, and we'll be happy to answer and get to them. I would like to take time out to especially appreciate Mafor for sharing, but also apologize. Today we shot our time. It's unusual. I think this is the first time ever. So I'd like to appreciate, but the conversation perhaps warranted it. So I didn't want to take anyone further. So apologies for that, and we'll make sure we do better in subsequent editions to honor our time commitment to you. Thank you for joining today. It's always great to have you. Thank you for all of the questions and contribution. Thank you, Mafor, and we look forward to connecting with you. Thank you once again, and goodbye for now.
Thank you. Bye, everybody. Thank you for attending.
Bye, everyone.